According to the National Electrical Code, specifically Section 250.53a, each service must have at least one grounding electrode system. Furthermore, Section 250.53b dictates that a grounding electrode system must consist of at least one grounding electrode driven into the earth. There are exceptions listed in 250.52a through a fifth, but the fundamental requirement is a grounding electrode. In your case, with 5 service laterals, you will require 5 grounding electrode systems. Each of these systems must have at least one grounding rod. Now let's discuss the grounding electrode conductors. Section 250.66 of the NEC specifies the minimum size for these conductors. For each grounding electrode system, the grounding electrode conductor must be at least a number 6 American wire gauge copper wire. Therefore, you'll need 5 number 6 American wire gauge copper grounding electrode conductors, one for each ground rod. Moving on to bonding to metal water piping. Section 250.104 of the NEC requires the grounding electrode conductor to be connected to any accessible metal water piping system on the premises. This means that each of the 5 panels needs a grounding conductor connected to the metal water piping system. In summary, you will need to run a grounding conductor from the neutral bus in each of the 5 panels to the metal water piping. Here are some additional notes to ensure proper installation. Firstly, make sure the grounding rods are driven into the earth to the required depth as specified in NEC Section 250.53b2. This section details the specific requirements for ground rod depth and spacing. Secondly, ensure that the grounding electrode conductors are properly sized and installed according to NEC Section 250.66. This includes proper connections and protection of the conductors. Thirdly, verify that the bonding connections to the metal water piping are securely made and maintained. This will ensure a reliable path for fault current. By adhering to these requirements, you can ensure that the electrical system is properly grounded and protected against electrical faults. It is important to consult the latest edition of the NEC for the most up-to-date requirements and to consult with a qualified electrician for any electrical work. The grounding electrode system plays a crucial role in electrical safety by providing a low impedance path for fault current to return to the source. This helps to trip over current protection devices, such as circuit breakers or fuses, quickly, which minimizes the risk of electrical shock and fire. The grounding electrode conductor connects the grounding electrode to the electrical system's grounded conductor, typically the neutral bus in the service panel. This connection ensures that the electrical system is referenced to ground potential. Bonding the metal water piping system to the grounding electrode system helps to equalize the potential between the electrical system and the water piping. This reduces the risk of electric shock if someone comes into contact with both the electrical system and the water piping. When installing ground rods, it's important to choose a location that is free from obstructions and where the soil is conducive to grounding. The ground rod should be driven into the earth until at least 8 feet of its length is in contact with the soil according to NEC 250.53b2. If rock bottom is encountered, the ground rod can be buried horizontally in a trench that is at least 30 inches deep. The grounding electrode conductor should be run in a straight line from the ground rod to the service panel, without any sharp bends or splices. The conductor should be protected from physical damage by conduit or other means. The connection between the grounding electrode conductor and the ground rod should be made with a listed connector that is suitable for direct burial. The connection between the grounding electrode conductor and the metal water piping should be made with a listed clamp or bonding jumper. The bonding jumper should be sized according to NEC 250.66, based on the size of the service entrance conductors. The bonding jumper should be connected to the metal water piping within 5 feet of where the water pipe enters the building. If the water meter is located outside the building, the bonding jumper should be connected to the water pipe on the street side of the meter. It's important to note that the NEC is a minimum standard, and local codes may have additional requirements. Always consult with the local electrical inspector to ensure compliance with all applicable codes. Grounding and bonding are essential for electrical safety, and it's important to understand the requirements of the NEC to ensure a safe and reliable electrical system. Properly installed grounding and bonding systems help to protect people and property from the hazards of electrical shock and fire. Firstly, proper grounding ensures a low impedance path for fault currents. Secondly, bonding equalizes potential, reducing shock hazards. Thirdly, compliance with the NEC and local codes is crucial. Remember to consult the latest edition of the NEC and a qualified electrician for all electrical work.